Hello everyone, I'm Yuzu Cai. I'm from National Taiwan University. I'm glad to share our work, SearchTrack, multiple object tracking with object customized search and motion-aware features. Given the specific targets, tracking is to maintain layer identities and yield layer trajectories from the input video. Our main task is multiple object tracking and segmentation. Unlike the setting in single object tracking and the person re-ID task, the input of the MOTS has an unknown number of targets and a known set of classes. Different from the MOT task, why do we need segmentation? Look at the bounding box in the image, which contains two people. Under this region-based representation, this situation will cause ambiguity and affect the results. We can prevent ambiguity if we change the object representation to point-based and add the segmentation mask. Most contemporary MOTS algorithms use one of the following instance queues: motion queue or appearance queue. Even some algorithms consider both queues. They consider the object appearance and object motion as two independent sources. In our observation, the tracked object in MOTS is highly correlated across consecutive frames. Our solution is to encode the object motion predicted by the common filter with the object appearance feature to produce a motion-aware feature. And we propose the object customized dynamic searcher to identify the association for a given object. To this end, we propose an algorithm to combine object appearance and motion cues to solve the association problem on the MOTS. Our method is an online, one-stage, point-based tracker, and our algorithm outperforms the state-of-the-art 2D online methods on the KITTI MOTS and MOT benchmark. In this paper, we also investigate the synergy between tracking and segmentation. Tracking can benefit from the dense pixel-wise annotations in our experiments. Networks can learn better separation of foreground and background in the scene. In this section, we will briefly go through the overall process of our method and explain how our dynamic searcher solves the association problem in the later slides. Our current implementation is built on the CenterNet detector, which identifies objects by layer center points. For segmentation, we adapt the conditional instance segmentation. First, a shared backbone network extracts features from the current frame and the previous frame. The extracted feature of current frame is fed to the search branch to form a search feature map. For a query object with ID I in the previous frame, we obtain its customized weight, theta, from the controller branch. Also, we obtain the predicted location M of the object from the common filter, and the location M is encoded in the motion map O. Then, we combine motion map O and the search feature map F to give us the motion-aware feature map F tilde. The customized weight theta realize a dynamic searcher T for the object with ID I. By taking the motion-aware feature F tilde as input, the dynamic searcher outputs a response map R indicating where the object could locate. This is another example with the object ID J in the previous frame. With different customized weight theta and the location M, we can generate different motion-aware features for the dynamic searcher to produce the target response map. Finally, a solver matches the boxes in the response map from the search branch and the candidate objects from the detection and the segmentation branch to resolve the association among objects. On KITTI MOTS dataset, we compare the published leading online 2D methods and one offline 2D method. Our method achieved the highest HOTA score among all online 2D methods. Also, our association accuracy outperforms all the compared methods. We compare leading published online methods on the MOT dataset with public detection. The results show that our methods achieve the best association accuracy among all the compared trackers, and our HOTA score is also competitive. For the ablation studies, we evaluate the importance of encoding motion into the feature map for search. With the motion-aware feature, the association accuracy and HOTA are significantly improved, especially for non-rigid pedestrians. By jointly training with the segmentation task, the tracking performance can be improved. Furthermore, because the backbone is shared for these tasks, the knowledge of foreground and background also benefits the tracking task. This is our result video on the KITTI MOTS dataset. This is our result video on the MOT dataset. In conclusion, we propose an online 2D method with comprehensive note of motion and appearance. By using dynamic convolution, every tracker has its own searcher. As far as we know, we are the first one-stage, point-based MOTS architecture. We further investigate the synergy between tracking and segmentation in our experiments. Thanks.